or converge. So here we can apply the ratio test or we can apply the root test. But let's apply the root test. The root test states if we take in the limit n goes to infinity, nth root, so just write infinity, n root of the series an with absolute value is equal with L. If L is less than 1, it means that the series is going to converge absolutely. But if L is greater than 1, the series is going to diverge. If L is equal with 1, so the series is inconclusive, according to this test. So now, if we are taking here a limit n goes to infinity, and nth root of n plus 1 over 3n. But here is with absolute value. But I'm not going to write any further absolute value because it's not going to affect anything in calculation, and I don't want to write some extra steps, some extra work here. So let me write here limit n goes to infinity. Now we can write this one here, we can divide this in two radicals, nth root of n plus 1, and down we can write the nth root of 3 in n. But this n here with the index with the power is going to simplify, and everything is going to be limit n goes to infinity, and down is a 3, and because just 3 is going to remain, and here is the nth root of n plus 1. And this third or 1/3 we can factorize. We can write 1/3 limit n goes to infinity, n is n nth root of n plus 1. But no, we are taking just this part here, just this part. So just let me go a little bit up. We are taking just this part here, and let's write this is equal with m. So this is equal with 1/3 of m. But no, let's work just with the m, just with this part inside, without this factor 1/3. If we're taking just the m, let's say m is equal with the limit n goes to infinity, nth root of n plus 1. And now we are taking a ln both sides, logarithm both sides, natural logarithm, let me go much easy. We can write ln m is going to be equal with the limit n goes to infinity, ln nth root of n plus 1. And now, but instead of this one, let me write in the fraction exponent, n goes to infinity, ln of n plus 1 in the exponent 1 over n. But according to the exponential rules, properties, we can write the ln m is equal with the limit n goes to infinity, and here is 1 over n times ln n plus 1. So we are here in this situation. And now let's work a little bit more. ln m is going to be equal with the limit n goes to infinity. So just let me write this a little bit better. So this I can write ln n plus 1 divided by n. And now if we are applying the infinity here, instead of the n, is going to be in the form indeterminate form, because it's going to be infinity over infinity. Therefore, we are applying here the L'Hopital rule, and if we are applying the L'Hopital rule, ln m is going to be with the limit n goes to infinity, and we taking derivatives here is going to be 1 over n plus 1, and if we take in derivative in the denominator is going to be 1. And everything here is ln m is going to be with the limit n goes to infinity and 1 over n plus 1. But now if we are applying here the infinity here, this is going to be 1 over infinity, which is going to be 0. This limit approaches to 0, and so ln m is equal with 0. If we are applying the e in the ln m is going to be e in 0, but this m goes into the front, and ln is a 1, m times 1 is just a m, and here e in 0 is 1. But we shouldn't forget here, m is equal with 1, but in the front we have 1/3, and now we already know this is series. So let me go a little up. We already know the series, what we had here, or limit, I'm sorry, n goes to infinity, what we have here, n plus 1 divided by 3 n is equal with 1/3 times m, which happens to be 1, but this is 1/3. So L is equal with 1/3, which means the L 1/3 is less than 1, and the series converges absolutely according to the, so this series here converges absolutely according to the root test.